Okay, thank you, Steve. And yeah, my talk's title is Exploring the Three Kingdoms with Graph Skills. If you haven't heard about the Romance of Three Kingdoms, that is the traditional novel from ancient China, and you will find the novel online and about almost everywhere you think. Yeah, so let's get started. And yeah, just before my talk, I'd like to introduce more about myself. My name is Jenny, and you can find my Chinese name on this slide. And I'm a developer advocate from Neo4j. You can follow me on Twitter. This is my Twitter handle. And the below is graph about my career, and I started my developer career from a travel agency, and I was a developer who built the front end website for them, and years later I started build a backend services, server side programming, and like that, and after years, I moved to an e-commerce company, and then I moved to another company. It was a air travel company. I almost work on the database and mobile and many other projects. So I mark myself as a full stack developer, and in the graph, the other 9 is from the community. I am active in the developer community, the open source community. I was containers at Microsoft MVP for 11 years before. Yeah, so the path crossed into the developer relations. So yeah, that's me. Topics in this talk, I want to cover about the novel itself, the Romance of the Three Kingdoms, and I want to show you how to build a people graph from the novel, and I will show you use Neo4j ORTB and workspace to explore the knowledge graph, and I will share with you some takeaways and main points of my talk, and what you can do next. Yeah. Yeah, just a little about the Romance of Three Kingdoms. It's very famous in China, but I don't know if you have heard about it. If you haven't, please search Three Kingdoms on Google, and you can find many images and even the novel itself, and many books and TV shows, even movies, I think. Yeah. It's about the ancient history. Three forces are competing to the nations, I think. Yeah. So let's look at a little more about the novel itself. There are 120 chapters of the novel, and there are many characters in the novel, about more than 1,000 persons there. Yeah, and you can find the novel raw text in the by the link on the slide. Yeah. So today I will use the raw text to build a people graph. The novel is in traditional Chinese text, and there are it don't looks like other data provide an API or something like that. It's just the raw text. So we will extract the data like people, like their relationship, like interactions from the raw text. After that, we're going to model the people graph and import the data into our Neo4j ORDB database, and so that we can start exploring the graph. Yeah, let's get started. So I will show you the code. Yeah, here is the Neo4j ORDB. You just learned about that. ORDB provides a free tier. And you can see I have a running free tier instance. So let's start with the import tool. It's the Neo4j data importer. Let me put my password. Okay, I will clear my. Yeah, as you just learned about the workspace, and workspace contain data importer, Neo4j browser, and Bloom into a single tool, but you can still access the data importer and the tools separately. So here is the data importer. Yeah, I will start with modeling the people graph with the data I have already extracted from the raw text. I will introduce how to extract the raw data later. Yeah, that's should be the hardest part. Yeah, sentences. Okay, sentences LDP and limbs LDP. Here are the files we need in the people graph. Yeah, like you can say, the sentences of file contains the every sentence in the raw novel, and the names CSV file contains every person's name in every single sentence. So I can link person name into sentence. So let's start modeling. Yeah, I will first put a chapter. Yeah, if you remember, there are 120 chapters of this novel. So from the properties, I will select chapter order and chapter name for the chapter node. The ID, I can specify the chapter order property. Yeah. Yeah, the data importer will help us create a constraint on this property. Okay. Next, I will create a sentence node from the same CSV file, and yeah, the sentence column. Yeah, you can just specify the sentence column as its unique constraint. You can see here is a relationship between chapter and the sentence. I will reverse the direction. Sentence in chapter. Yeah, that's the type of the relationship. And from sentence, yeah, it's a sentence. And to chapter order, yeah, that will show us a sentence belongs to a chapter. Yeah, here's a very simple model. So I will add another node. I will name is person. Let me see. From the names, save the file and select person name as its property and also the unique constraint. Yeah, we know that the person from the raw text, they are appears in every sentence, every paragraph, and yeah, we will name this relationship is mentioned in a sentence. A person is mentioned in a sentence. Yeah, that's the relationship. And from person name to sentence. So yeah, okay. Here is our very simple model. So let me click the preview, and you can see how the graph looks like. The blue node is a chapter node. You can see there are many sentences around it, and you can also have person nodes here, and they are mentioned in a sentence. And say a sentence can contain many persons in a single sentence. Yeah, looks great. So I will click the run import. You can see the progress here. The data importer is importing the data to the NeoDB instance. It should take a few seconds. Okay, done. And you can say chapter node, sentence node, and person node here. And in chapter, mentioned in relationships here. And also you can check the query, the cipher query here. So as I said before, it helps us create a constraint for the nodes. And here is the node data queries. Yeah. So what's next? Yeah, we can start querying the pico graph. I just opened the Neo4j browser here. You should remember your password, and yeah, it will ask you for that. Okay, here is the Neo4j browser, and you can input cipher here and run the cipher to query the graph. Let me first check the schema. Okay, that looks like perfect. The same as we model in the data importer. Yeah, person mentioned in sentence, and sentence belongs to a chapter. Yeah, it's very simple. So what's next is let's start explore the graph. Let me show you. Okay, I will drag my queries from the notebook. Okay, here is a query. It will tell us who has the most mentioned times. Yeah, maybe wrong. Yeah, you can say that a person name here and mentions count here. Yeah, Ming is the most mentioned person in the level, and Cao Cao and Xuande. Yeah, Cao Cao and Xuande is the same person, so there should be many problems to about the data processing. Yeah, I will talk about that later. But you can say the person network here. Okay, the other question is on which chapter has the most persons there. Yeah, you can use this query and match start with a person node and mention it in sentence and in chapter. Okay, and we will count distinct person name. Yeah, let's run that. Yeah, I made a mistake about the data importer. The chapter order should be let me find that. It's not a Boolean type. I will change it to integer because we have 120 chapters there, but it created for us specify a Boolean type. Okay. Yeah. If we can just run import directly, and the data importer will merge the data for us. Okay. Okay, let me check that. Maybe I need to remove the false data. Okay, I will remove the chapter data first. Okay. You can see there are two more extra chapters there. So I will run the import again. I hope it works correctly. Yeah, it should work. Yeah, you can say in the chapter 91, there are 141 persons there. And yeah, that's the chapter has the most persons. Yeah. So next question is, we can query a person and in which chapter, just show the path. Okay. Here's the person Cao Cao, and here's our sentences here, and the sentences are belongs to chapters. You can say Cao Cao is mentioned in many sentences and many chapters. Yeah, that's the really simple path here. Yeah, let me show you a more complex query here, and you should want to know that who is mentioned in most chapters. Yeah, we can start query like from the person node and mention in, and in chapter this is a pattern, and we can count the chapters here. So let's run it. Okay, you can also Cao Cao is mentioned in many chapters, like 86. You know, there are in the total there are 120 chapters. So yeah, that's a lot. Yeah. Here's a character about it's a word just like you and him. Yeah. So that's another work to do about the data extract process. Yeah. Okay, now we don't have, as you can say from the data importer, we don't have people, we don't have relationships between people. So next, I will start create a relationship between them. You know, in Laravel, there are many sentences, and um, the sentences describe the interaction between characters. So we will follow that if more than one people mentioned in a sentence, we think that uh, they have some uh, relationships, or we call interactions. So we will find people in a sentence, and will create interacted with relationship between them. So here is a cipher query to do that. Yeah, the most thing about it is connect the person IDs and create relationships between them. Yeah, first, it will help us find who are in the same sentence. Yeah, so let's run that. Yeah, we'll wait a few seconds. Yeah, it said created 21,000 relationships about the interactive. So that should be a very big graph. So now we have the people interaction network. You can run the DB schema again, and you can say person has interacted with relationships to itself. Yeah. So let's start explore uh, more about the interacted with a relationship. Here's a query about how many interacted of a person. Yeah, let's find the most people. Okay, total again and commit again, and you can say they are very important in the level because they have the most interactions. And we can also query the interactive path, um, like we want to find the Taotao's interactive network. So let me do that. Okay, you can say where is. Okay, here is Cao Cao, and he he has most interactions with these people. Yeah. Since we lost the labels in the circle. Uh, so let's see the name um, of the circle. Yeah, that's the most interactive network from the level. Okay, and we can also query the um, network about friends of friends, something like that. And here is a query from this person to this person, and they don't have directly relationships. So from the people network, let me find out how can they connect each other. Okay, it's a very big graph. And you can say, okay, let me find. Here is the node 2, here is the node 1. you can say there are many possible paths between them. Okay, I think that's some interesting or very funny queries from the people graph. So let's do some exploring from the third tool called the Overlay Balloon. We'd like to create a new thing. Yeah, you can say there are three nodes: chapter, person, and sentence. So yeah, you can input queries in the input text in the input of the bloom. Like you can select person and interacted with person, and you can browse the relationship. Okay, it's a very big graph here, but you can see some clustering there. Um, from Bloom, you can very easily explore the much more bigger data size. But before we do that, I'd like to update a property about the data. So as you can see, we have the interacted with relationship, and we'd like to set a property on person node that specifies the interact count. Yeah, let's run this query. Okay. So from Bloom, you can configure the person node, and you can configure its size and color, and based on a property like interact count. So let's do that. Okay, maybe then we create the rule. Okay, we will refresh our perspective at first. Yeah, because there are new properties. Okay. Yeah, we have the properties. Let me reduce the amount of the graph in the scene. I have another query about the bloom. You can specify your own query here, and yeah, here is some queries about the chapter 1 network. We can just put the interaction networks from chapter 1. So that should be a small size network. Okay, you can see there are 78 nodes in chapter 1. Let me configure the size again. Okay, refresh again. interact count, right? Okay, we can have color here, and where is the size? Okay, let me make it much huge. So yeah, that's it. You can see in the big and the deep nodes are the most interactive person here. Yeah, that's just from the chapter 1. So we can also add chapter 2 network here. I just run another query. Yeah, so you can say more nodes added to the scene. Okay. Use Bloom, you can easily and very visualize about your data and your graph. Okay, that's the Three Kingdoms people network. You can use them as a very started project. So let's back to this slide. Yeah, that's the code and the graph. If you have any questions or suggestions, please put them into the chat. Yeah, so yeah, let's share one more thing about the hardest part of this graph building journey. You know, the novel is in traditional Chinese, and it's very hard to understand by human beings. So if we want to use that as a data source, the computer, um, it's much harder to understand the traditional Chinese. So I like to recommend to use NLP, natural language processing toolset to do that. And yeah, that's the hardest part. I think that's the hardest part about many data projects. So my suggestions is starting with sample data and smaller data to do that. And another suggestion is to use very easy tools to get started, like Neo4j ORDB and Desktop and many other developer tools. Yeah, and you can find my code in this GitHub repo address. Yeah, thank you.
Super. Thank you. Thanks so much, Shiny. It was a great
Yeah,
presentation. Uh, we have a lot of questions in the chat. Let me just
okay.
take one by one. Okay. So Jay is asking, did you model after extracting raw text or after that? Before
Uh,
extracting the raw text or after that?
yeah, yeah, I put
I
the
think
raw
this is
text. Maybe I forgot the hardest part. I extract the full level from the raw text. Yeah, so you can let me share my screen again. You can see. Yeah, you can see in my GitHub. And yeah, here is the raw text, and you can see there are 120 chapters. Let me click the first one. Yeah, here is the raw text. And the hardest part should be here, how to get the raw text or how to get the raw data. Um, I know many people are using Python or Scrappy framework. Yeah, I'd like to recommend use APAC. Yeah, Neo4j APAC can do that very easily. With this cipher query, you can pull down the whole novel from this website. Yeah, yeah, that's a raw data. And the
awesome.
second one is how to extract sentences or words or person names. I use an LP, the framework called LTP from a university from China. Yeah, it supports um, Chinese very well. So you can see the Python code here to do that. Yeah.
Okay. The next question is by the same person. How many languages does Neo4j support? Is there a link that we can refer to?
Yeah, I'd like to say more than you think. You know, there are many ancient languages in China, and yeah, I'd like to share a community story with you. Um, one day, a person reached out to us and told me how to extract a tongue character. I don't know how to pronounce that from the ancient novel like that. Yeah. Yeah, actually, I have that photo on Twitter. You can find that there. Yeah.
All right. Is there a link by any chance, Shiny, that you can share it with everyone?
Um, I don't think we have a link about that, but you can find many um, like encoding tips from our documentation. Yeah.
Mm-hmm.
Yeah.
Okay. Sounds good. And yeah, there are more questions coming up. So the next question is by Conrad Taylor. He asked, "How does one get back to console window from data import window? Is there a link on the page, or just need to enter the URL?"
Um, yeah, like you can say I just click the three buttons there, and yeah, it will open three tabs for us. But if you use workspace, you can just easily switch the tab in the page. Yeah.
All right. And I think this is probably the last one.
Okay.
Uh, Farhan is curious to know how to provide battle or fight relationship between characters in this story.
Yeah, that's very funny. As you can, yeah, as you know, I just started exploring the ancient novel data set, and there are many examples um, show how to explore the uh, relationship more than people interaction. Yeah, yeah. I'd like to say, please check out my repo later. I will share more about that. Yeah,
All right, great. And I'll just share the link of GitHub again,
yeah.
broadcasted it for
Thank you.
everyone to make a note of it.
Yeah,
Thanks, Sima, as well, for sharing it across. Yeah, I think those are the questions that we have. It was a really exciting session. I learned a lot from the session
yeah.
today.
Thank you.
Okay, perfect. Cool. Thank you so much, Shiny. I think we have more time to take up more questions. If you have more questions, you can just quickly share it in the chat window. We can take up a few more before we move on to the next session. We have time for the next session to start up.
Hmm.
So maybe you can take a snack break if you want.
Yeah.
You can stay hydrated. Perfect. Thank you. Thanks so much, Shiny. I
Thank
think
you.
that's it.